All right, hi everyone. Today we're going to start chapter 7, which is all about exponential growth and decay. So we're going to start with just looking at what exactly is an exponential function. We're going to look at how we define it, what the equation looks like, what the graphs look like. So we're going to focus today on just the basic exponential graphs. And then from there we'll work on some other things in the next video. So today we're going to look at defining what an exponential function is. So it's a function whose general form is f of x is equal to ab to the x. Now the only thing that's being taken to the x power is the b, not the a. So let's think of it as base. And notice that the variable x is an exponent. We haven't really dealt with this before because our variables were always being taken to a power. All right, so how do we deal with a variable that's our exponent? So we do have some requirements here. We have to make sure that our number in front, a, can't be 0 because that wouldn't make any sense. 0 times anything is this 0, and it's kind of pointless to look at. But we also have that the number is being taken to the power is a positive number. So it could be 0.4, it could be 17, all right? But it can't be negative. It can't be like -1 or -20, okay? And that it can't be equal to 1, because again, 1 to any power is just 1. So that's kind of pointless to look at, all right? So we're going to take a few minutes. All right, we're going to complete the chart that's below. All right, so we're going to graph 2 to the x and 1/2 to the x. And we're going to state the domain range, where it crosses the x, where it crosses the y. And are there similarities and differences between the two graphs? So what you're going to want to do is, using a calculator, I gave you numbers from -2 to 2 in increments of 0.5. And you're just going to fill out the chart, put that in for x. So take a minute, pause the video, fill out the chart. All right, so let's take a look and see if your numbers match mine. So here are my values. So when we take them to negatives, notice it's decimals for 2 to the x up through 4. And you should notice that there's some unique things happening here where 2 to the second is 4 and 1/2 to the -2 is also 4. That's just a property because our bases are reciprocals of each other. That doesn't always happen. All right, so let's graph these two and then talk about domain and range. So I'm going to use like pink, fuchsia, whatever, to graph 2 to the x. Okay, so -2 was 1/4. Okay, 1.5. Okay, 0.5, 0.71, and then I got to 1. All right, 1 and 4. Then I got to 2. Then 2.82. And then all the way up to 4. So you notice that after the decimals, it increased. Okay, one of the things that you should notice is none of our answers are negative. All right, so let's try the other one. Okay, so at 2 we were at 4. There we go. And at 2. Then 1.4, 1.7, 0.5, 0.35, and down here at 1/4. I don't like the placement of that one. Let me fix that. It's 2.82. All right, so if we look at the blue one, which is our 1/2, okay, so these guys actually are mirror images of each other across the y-axis because of they're reciprocals of each other. But what we do notice is that our integer 2 is increasing and our fraction is decreasing. Okay, so because he's decreasing, he's called decay. And because the 2 to the x is increasing, he's called growth. So there's a lot of applications that we're going to look at with our exponential models. All right, so let's take a look. I asked you to find domain and range. If you noticed, we could put any numbers into the function. So our domain is going to be all reals. Okay, and again, you can make note of that with the negative infinity to infinity. All right, but our range is only positive values. In fact, we're not even getting 0 as an answer. So you can talk about it as y being greater than 0. You can have a parentheses 0, comma, infinity. Either one of those is going to represent only positive solutions. Then I also asked for where it crosses the x. So the x-intercept, it doesn't. There is none, okay? And the x-axis is more along the lines of a guideline, which we're going to refer to later on as called an asymptote. And we'll define that a little bit later. But it is more like a guideline where the graph gets very close to but never crosses. And the y-intercept, if you notice, both of these cross the y-axis at 1. Okay, right there. And that's because when we take anything to the 0 power, the answer is 1, if you remember that. So that's important to note, that our exponential functions are always going to intersect the y-axis at 1 unless there's a number in front like a. All right, so let's take a look at explaining the difference between this growth and decay concept. So exponential growth, and our formula, remember our form is always going to be f of x is equal to ab to the x. Okay? So remember, f of x and y are the same thing. All right, so here, if a is greater than 0, so in other words, the number in front is a positive number, b is greater than 1, then this is a growth function, okay? So our number in front has to be a positive, and the number that's being taken to a power is a number bigger than 1. So it could be like 1.5, it could be 10, it could be 3 1/4. As long as it's bigger than 1, you're going to get a growth function. For decay, let's give an example here. So an example might be f of x is equal to 2 times 3 to the x, where 3 to the x is our base is 3, our a is 2, and our exponent is x. Now for decay, a is still going to be greater than 0. That's part of the definition of exponential functions. It can't be 0, but we're going to use strictly going positive now values. And b is going to be between 0 and 1. So we're talking fractions here, decimals. Non-negatives, so we can't be bigger than 1. So we're talking like 0.5, 0.7, 0.99, any of those. So for example, our function might be 6 times 0.3 to the x. Okay, and that would be a decay model. All right, so let's take a look at these problems. All we're going to want to do, oh, by the way, remembering that a is always going to be our y-intercept. And again, it's because if we put 0 in for x, b to the 0 is always going to go to 1. A times 1 is just a, so he's always representing the y-intercept. All right, so let's take a look at these. We want to know, is it growth or is it decay? And then state the y-intercept. All right, so the first one here, take a look at what's being taken to the power. So that's 4. That is a number bigger than 1, so this is a growth problem. Okay, and our y-intercept is a, which is the number in front of that, which is 0.75. Okay, let's try this one. Okay, well, again, we're taking a look at what's being taken to the power, which is 0.05, which is between 0 and 1, so this is a decay problem. And our y-intercept is 0.63. Okay, all right, so let's try this one. 0.83 is being taken to the power, so that's decay. And our y-intercept is 9. Okay, all right, take a minute, Let's see if we'll do these together, see if we all get to the same answer. This is not decay, this is growth, because 6/5 is bigger than 1, and our y-intercept is 1, because there's no number in front. Okay. All right, so we're going to graph these now. So let's take a look. Okay, let me know if you have questions on the difference between growth and decay. All right, so let's graph these. So we're going to do 4 to the x. Now, the easiest way I can tell you to do this is let's make a little mini chart. Okay. So I'm just going to pick some values that I know that I can work with. Okay, so for example, I know 0 is always going to be 1, okay, unless there's a number in front. So let's pick, because I can put any number in, let's pick -1 and 1. So if I put -1 in here, that's 1/4. And if I put in 1 in here, I get 4. Okay. All right, so -1 is 1/4. That's really tiny. 1, and I know this is going to be 4. Okay, so this is a growth as well. Okay, so I would want to identify whether it's growth or decay, where it crosses the y-axis, and then pick some points. Okay, so this problem is a decay because 1/3. Okay, our y-intercept is 1. And I'm just going to pick some points to put in for x. And we could pick like 3, that works great. So x, y, I'm just going to keep picking -1, 0, and 1. So if I put in -1, 1/3 to -1 is 3. This is going to be 1, and this is going to be 1/3. All right, so over -1 up 3, 0, 1, and over 1, 1/3. So this again is a decay, so we know it should look decreasing. All right, let's try one more. Or sorry, 2 more. All right, so if we look at 3 to the x, we know this is a growth problem. All right, we know that there is a number in front of being taken to the power, so our y-intercept here is 2. So again, I'm going to make a little chart. And again, I'm going to use -1, 0, and 1. Okay, so 3 to -1 is 2/3. And then, I'm sorry, 3 to -1 is 1/3, times 2 is 2/3. Okay, so this is going to be 2. And then 3 to the first is 3. 3 times 2 is 6. Okay. If it helps, okay, use your calculator or go to Desmos. And hopefully that'll help you put your head around where I'm getting these points. Again, I'm just picking -1, 0, and 1. I'm putting them into the equation and then figuring out the y value. So -1 is 2/3, 0 is 2, and 1 is 6. Okay, notice the difference. It's increasing faster if there's a number in front. All right, so let's try one more problem. Okay, so we have, this is also a growth problem because 5 is what's being taken to the power, and our y-intercept is 2/3. Okay, so I'm going to pick some points. Again, I'm just using -1 and 0 and 1 just because those are easy. So if I put -1 in there, 5 to -1 is 1/5 times 2, so that's 2/15. Okay, if I put 0 in, we're going to get 2/3. If we put in 1, 2 to the first is 5, and then 5 times 2/3 is 10/3. So that's 3 1/3. Okay, so that's what I'm going to graph. Okay, now 2/15 is really small, so I'm just going to put it pretty close to the x-axis. 2/3 and 3 1/3. So there we are. Ride the x-axis and then go up. All right. Okay, so let me know if you have any questions. And remember that we're going to stay in, so it means that we're all going to stay safe. Have a great day, guys.